We start our story in Paris in the 1630s. Mersenne is a friar in the Mennonite convent of the Annunciation. The Mennonites, as the name implies, are a relatively small and humble order, but they have built for themselves a reputation for scientific investigation, with Mersenne amongst their most celebrated experimenters.
Sed libera nos a malo. Amen.
Mersenne himself made a study of the nature of sound. His love of music made this a natural choice for his inquiring mind. But it was a subject not much studied at that time, and Mersenne was one of the first to do so. He discovered, by experiment, that the pitch of a plucked string is affected by several factors. First, it was proportional to the square root of the tension. Secondly, it was inversely proportional to the length. Thirdly, it was also inversely proportional to the square of the diameter. This formula was Mersenne's own discovery. It was completely new, and actually contrary to the accepted Pythagorean view of the relationship between tension and pitch. But Mersenne wasn't content with just an experimental determination of this relationship.
But why should this law hold? How can I prove mechanically that this law must hold true? I know that it is true to within the limited precision of my experimental observations. But can this formula be proved with the certitude of a mathematical explanation? The tension governs the movement of the string. But what is the nature of this movement? I have determined, using very long strings that vibrate very slowly, the manner in which the string behaves. But what are the physical laws that determine the manner of this vibration and relate it to the tension? And what of the harmonics of a plucked string? Without changing the length or the tension or any physical aspect, I can cause the string to behave differently. And produce notes of several different pitches. Now this I find puzzling enough, but I have listened deeply to many notes, and I have determined that plucking an open string can produce as many as 5 different tones at the same time.